Students, Mr. Gootz here. We'll be going over page 381, problems down here. These are the sum and difference formulas. And again, the idea here is that you can get weird angles that are a combination of other angles. Like 165 as a combination of two angles we know. Now what's different about these is, like 105 is 60 and 45. Those are both in quadrant 1. Those are both easy to draw in triangles. 135 is not in quadrant 1, so the triangle might be a little bit tricky. So that's what I'm going to help you out with. So first, let's see, we're doing 165. And we did an example with the sines and cosines. So what I want to do is do it with the tangent, because the tangent is a beast. It's its own ginormous nightmare, which you're going to see, and I'm going to help you out with. So, there it is. Why is tangent a problem? Well, take a look at this. Sine and cosine are just multiply, and then you add something right here. And then tangent, you get a fraction. You're adding something on top, you're multiplying something on the bottom, and a 1 minus. Okay, not that big of a deal, the 1 minus, but because you start with a fraction, and you have addition on top and multiplication on the bottom, you're going to need to simplify the fraction probably, and that's where our problem comes in. All right? So just a warning, if you did not match the back of the book, and you're all, screw this, don't worry. You might have done it totally correct, and maybe you just didn't simplify down to the level they did. Not that yours is incomplete. It's just that there's different levels of simplification sometimes, and I'll show you what I mean by that. So let's not dilly-dally. What the hell does this mean? This means what we're trying to do is tangent of 165, but what we're really going to write is tangent of 135 plus 30. And according to this rule, that would be tangent of 135 plus tangent of 30 over 1 minus tan 135 times tan 30. Okay, whoops, I'm sorry, you can't even see that. Make this a little bit better. Okay, so that's what we did. This is the formula. I would not ask you to memorize this, but some teachers will. So just in case you take calculus next year, I'd just like to let you know. It's a big pain in the butt. This is derived from somewhere. It's in the book. We're not going to go through it right now. The thing is, though, a lot of what we get into this chapter is pushing around equations like this. And so anytime I can come back to our triangles, that's what I'm going to do. And that's what we're going to do here. What the hell is tangent 135? What the hell is tangent 30? Let's start with a 30, because 30 is easier. 30 is your 30, 60, 90 triangle. We've said it so many times, you got to know it. 30 is the small, 60 is the bigger, and 90 is the right angle. So 1 is the small, 2 is the hypotenuse, and rad 3 is the weird side. So tangent of 30 is opposite over adjacent. 1 over rad 3. That's the ratio, opposite over adjacent. All right? And here's where we get into the issue. You could leave it like this technically, but the book doesn't like to leave a radical in the bottom. And again, the reason for that is a square root like this is not, it's a never-ending decimal. So 1 divided by a never-ending decimal is kind of weird. So it would be better if we had the never-ending decimal on top. You might be like, well, does it really matter? Well, sort of yes, sort of no. But let's do this one step. Multiply it by itself on top and bottom. And you can do that. 5 over 5, 3 over 3, 2 over 2, whatever. And when you multiply, you get rad 3 on top, rad 9 on the bottom, and square root of 9, radical 9, is the same as 3. No radical anymore, because we did the operation. So that's what tangent 30 is. We're going to be able to plug that in back up there. Okay, because that's where we get our values. Okay. 135, what the hell is that? Well, let's draw it here. 135 is in quadrant 2. So 135 is all the way over here. And so what it is, and that's a poorly drawn triangle, but we'll deal with it. That's a 45. How do I know that? Because you went 90 plus another 45, that's the same as 135. Okay? And so what you got is you got yourself a 45-45 triangle. And that's a 1, 1, and rad 2. Okay, always, always, always. However, because we're in quadrant 2, your x-coordinate is -1, and your height here is a +1. So your adjacent side is a -1, and your opposite side is a +1. So again, tangent of 135 is from this angle. So 135 gets us this location, so we're looking at a 45-degree angle. tangent of 135 is the same as this, is opposite over adjacent. 1 over -1, which is just -1. Well, hey, that doesn't seem that bad. What's that mean? That's going to go plug in up here for 135. So let's get to the work of it. So that equation of the tangent 135, instead of tangent 135, we're going to put -1. Tangent of 30, we said was rad 3 over 3. All right, that's the top part. Bottom part's 1 minus tangent 135. We said tangent 135 is -1 times tangent of 30. Rad 3 over 3. Okay, so it's tangent 135 plus tangent of 30. 1 minus tan times tan. So there you go. Wouldn't it be nice if we could leave it like this? Technically, you're done. Technically, we've done all the trig. Honestly, the trig is done. The rest of this is not done. It's a lot of pushing around algebra. Okay, so we can only do one thing at a time here, and that's the main thing I can tell you is relax, take one thing at a time. So you got a very complex fraction here. So let's take the numerator first. What can we do? And you're like, oh, I don't know. Can we add these? Sort of. You can only add if they're both fractions. So let's make -1 a fraction. 3 over 3 is the same as 1, so -3 over 3 is -1 plus rad 3 over 3 over, so that's that. Okay, now they have the same denominator. On the bottom here, we're going to use the same trick. This 1 is going to become 3 over 3, and then 1 times rad 3 over 3 is just rad 3 over 3, so that's safe. And then the negative times the negative is a positive. So it almost looks like we could cancel stuff here. We cannot. Okay. Let's slide our paper over. And again, why we did this, why we did all right that right there, so we can add them. Okay. So they have the same denominator, 3 over 3 plus rad 3. Sorry. We can put it all together as one fraction over 3. That's what I meant to draw. Same thing on the bottom here. This is 3 plus rad 3 over 3. So it's a common denominator, so you make it a fraction with a single denominator. Like, oh, crap. Where do we go now? Okay, well, this isn't that bad. We're getting there. We're getting there. This is the same as like having 1/2 divided by 1/3. In that, you take the numerator and then reciprocal the denominator. And then that would be 3 over 2. Well, this is a little bit more complicated, but it's the same idea. The numerator times reciprocal. So we're going to flip that over like that. That one's flipped over now. Now, before things get confusing here, this is a binomial pair. This is a binomial pair. That's like a married couple. They're not going to split up. This is solo, and we're multiplying and stuff like this. These are common factors. They're going to cancel each other out. Woohoo! Then across the top, you got -3 plus rad 3 over 3 plus rad 3. Whoa, let's move it over. Now, wouldn't it be wonderful if these canceled? Things don't work that way. These are married couples. So even though they look the same, we can't cancel individual factors. Okay. Now, technically, if this was a quiz, I would let you stop here. Problem is, the book does not match that. Okay, so what the hell? Well, I want to make sure you're prepared for calculus, and this is, like I said, one of those pain in the butt things about calculus. So technically, you'd have to ask your teacher next year. This used to be okay. Or, I mean, sorry, this used to be, they'd ask you to go further. Now, maybe it's okay. I honestly don't know what the AP wants anymore. It's been years. Well, let me show you what you're going to do, though. It's going to get ugly, and I warn you. Let's go ahead and continue. I'm going to start a fresh paper. So you can stop here because we're trig, but if you want to know how to simplify an ugly thing like this, we've done this before. If we have 1 plus rad 3, we use the reciprocal, not the reciprocal, the conjugate. You do the opposite of it, and then you have to FOIL this whole thing out and multiply everything. That's what we're going to have to do up here. So I'll show it to you because it's necessary. And like I said, this is like running the mile in PE. It's a pain, but it's necessary. It's like weightlifting. I hate it. No, yeah, I don't go to the gym a lot. It's something I hate, but it's probably necessary. Something I should do if you want to build muscle and stuff like that. And then this is part of building math muscle. Okay. And just a quick side note: I've known teachers that do the crossword every day, not because they enjoy it, but because they think they're building their brain muscle and it's going to make their brain less likely to get Alzheimer's. Well, I don't know. We'll see. Anyways, let's go through this and just foil this thing out. Let me see if I can find some paper to cover this out. Let's foil this. Let's see if we can get another color here. All right, so 3 and 3, that's 9. It's a long video here. I apologize, guys. That's -9. This stays outside, that stays inside, so it's 3 rad 3. Because 3 on the outside, 3 on this side, and then negative makes it plus. Oh yeah. 3 rad 3. And radical times a radical, well, we get radical 9 inside. Alright. Looks ugly, don't worry, we're going to get it better. Same thing on the bottom, but check this out. 3 times 3 is 9. 3 in this radical is minus 3 radical 3. Right here, 3 radical 3, and right here, minus radical 9. Like, wait a minute, there's some things in common here. Okay, so on the top we can't really do anything, okay? But on the bottom right away I see these are exactly the same. One's positive, one's negative. That's beautiful. This does not work on top. But it works on the bottom because that's the whole point of the conjugate. That's the whole reason we use it. Okay, what the hell is this? Takes us one step at a time. -9. 3 and 3, so this is like 3x plus 3x. It's 6x, or 6 of these radical 3's. Radical 9 is just 3. Oh my goodness. Almost done. 9 minus radical 9. So that's 9 minus 3, which is -9 plus 6 radical 3 minus 3 over 9 minus 3 is 6. On the top, the 9 and this, they're both can be combined because they're whole numbers. And you get that. Now don't screw this up at the last step. You can't just cancel those. What you can do is rewrite it as 2 separate fractions like that. Excuse me. You can split into 2 separate fractions when you have a single denominator. What the hell is this? That's -2. What is this? 6 divided by 6 is 1 rad 3 or just rad 3. So that's what they get in the back of the book. And you're like, how in the hell did they do that? Well, they sort of did all of this stuff. All this work. So it is kind of a pain, okay? But like I said, you got to realize you're getting tougher here. I would never assign you 30 problems like that. That's a pain in the butt. But it's good to know how to do that. All right, it's just I can't explain where it will come up. But there's times in like even in statistics where you'll do radicals and you have weird funky equations in physics as well, in chemistry. So it's kind of, why did they make you take it? To prove you can do it. All right, it's kind of like that. That's why they want to prove you're tough enough. So you show you're tough enough, you can do this stuff. Like I said, is it the trig that's tough? No, not really. The trig was these triangles. So when people say is calculus tough, no, the concepts aren't. It's this stuff that really is a pain. So just practice it. You're maybe not going to love it. Or maybe you will. But it's most mathematicians don't even love it. But we get through it, and there's a light at the end of the tunnel. And so thanks for watching. Stick with it. And wow, this is the longest video I've ever made. Thanks for sticking in there, guys. All right. Take care. See you next time.